Hi there, it's Grant the SAT Genie, and we're going to take a look at exponent laws. These are some of the basic algebraic principles that you're going to use to break down a lot of problems on the SAT and score a lot of points. So before we get into the different rules, it's important to understand what an exponent is and how you can use your prior knowledge to understand challenging questions. Essentially, if you have something like x to the a, that's a statement saying, please take a copies of x and multiply it. So you would do x multiplied by x, multiplied by x, multiplied by x, dot, 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 a total of a times. So, of course, and let's look at a concrete example that we can understand. If we have something like 3 raised to the power 4, well, that's the same thing as 3 times 3 times 3 times 3. 3 copies of 4 multiplying, and that's one that we can simplify. That's just 81. Okay. Another thing that I want you to understand, and this is a really useful trick to understand something that fools a lot of students, is this is a positive exponent, and it's telling us to multiply that 4 times on the top of a fraction. If we had something like 3 to the negative 4, this is a set of instructions telling you to divide by 3 that many times. What are you dividing by 3? 1. Divide 1 by 4 copies of 3. So 3 to the negative 4 is not negative 81. It's 1 over 81. Okay, so this is our answer for this question, 3 to the negative 4. So positive exponents multiply by that many copies of the base. Negative exponents divide by that many copies of the base. Okay, now, because of these natures of exponents, it leads to some interesting properties. For example, if we multiply exponents, then we can add the exponents together. And let's take a look at why. If we had something like this, let's say x to the 3 multiplied by x to the 4, well, that would just be, well, let's do x to the 3. Okay, x to the 3 is 3 copies of x multiplying. Okay, triple x. Really spicy questions today, Grant. All right, and then we'll do x to the 4. That's 4 copies of x multiplying. And if we look at that, well, that's just 3 copies and 4 copies all multiplying. So this is the same thing as saying x to the 3 plus 4 or x to the 7. When multiplying exponents of the same base, when multiplying powers of the same base, you add the exponents together. Cool, right? So we can use that to simplify questions like the one on the left. So let's take a look at this example. In these cases, because multiplication, you can do it in any order, we can organize this in a way that's much simpler. So I can say that this is the same thing as, well, it's equal to negative 11 multiplied by negative 7. So I can do the numbers at the same time. X to the 4 multiplied by x to the 5, and y to the 3 multiplied by y to the 7, y to the 5. You can see it that way. You can write it down if you need to do that to avoid errors. And then we can just do that. Negative 11 times negative 7, well, that's easy. That's just 77. And positive because a negative times a negative. X to the 4 times x to the 5 is x to the 4 plus 5. X to the 9. And y to the 3 times y to the 5 is add the exponents together, y to the 8. So let's go ahead and proudly type in our answer, was x to the 9, and then y, oops, my keyboard is set to French. All right, x to the 9. Okay, let's get that. Let's do this. How about, all right, I'll save you watching me type it. Let's see the triumphant return of the green check mark. All right, and remember this important step. So let's take a look at a new one. Now, you don't have to write these out if you can do them in your head. So I look at this one, I see that this is equal to negative 9, and then I just look for my power of x, x to the 8, and then y to the 1 times y to the 3 is y to the 4. Okay, so this is y to the 4. Why is that y to the 4? Well, let's take a look. If I have negative 9 x to the 5 y multiplied by x to the 3 y to the 3, this is a set of instructions saying multiply by y once. that's y to the 1. If it was y to the 0, it would not be there. Okay, so we submit that answer, and it's correct. All right, so we definitely want that skill of being able to multiply powers and to do so quickly, so that it's not something you have to stop and think about. Definitely unconscious competence for this skill. We definitely want that. Now, what about raising powers to powers? Let's take a look at what we need to do if we have 5x to the 3y raised to another power. Okay, and let's, of course, when you get tricky problems that look like that, you want to start by relating that to something simpler that we can understand more easily. Let's say I have x to the 3 and I want to square it. Squaring something means multiply by 2 copies of that thing. So there's 1 copy of x to the 3, and there's another copy of x to the 3. And I see that, if I then expanded that, that'd be triple x multiplied by triple x, which we don't need to get into because we can see, well, here, I remember that I can just add those exponents together. So this is x to the 3 plus 3, or x to the 6. But we could have also just noticed that that's 2 sets of 3. 2 sets of 3, another way of thinking about that is x to the 2 times 3. So in these cases, we can multiply the exponents. So this is x to the 2 times 3, or x to the 6. Okay, so in this case here, our first step is going to be write out the question. 5x cubed y, all raised to the power 4. I don't want to write that out 4 times and do 4 copies of it. I'm just going to multiply the exponents. So in this case, I'm going to have 4 copies of 5 multiplying. I'm going to have x to the 3 multiplied by 4. That's 4 copies of x to the 3 multiplying, or x to the 12. And y to the 1 times 4. Because don't forget, there's a 1 in there. And notice that we do that 4 to all of those things in that bracket. So 5 to the 4 is 6125? 6125. And they would give you that on the calculator section. Why am I forgetting? It's embarrassing. 5 to the 4 is equal to 625. Where'd that extra 1 come from? It's very strange. It's very late. X to the 12, y to the 4. Wow. Okay, and so then we probably put that in as our answer. 625, x to the 12, y to the 4. Hooray. Don't add an extra 5,500 to your answers. All right, so that's how those work. Let's take a look at another example. Okay, and we want to be able to do these in our head. All right, so 3 to the 5 is 243. X to the 4 to the 5 is x to the 20. And y to the 2 to the 5 is y to the 10. That one in my head. There, good. I'm back. I'm back, everyone. I can do powers up to 5 and not have to check a calculator. So that's raising powers to powers. Now, what about dividing powers? Let's take a look at those. Okay, in these cases, it's helpful to remember that idea that an exponent is multiplied by that many copies, but a negative exponent is divided by that many copies. However, in this question, it says please only use positive exponents. Now, let's take a look at our dividing powers rule, or otherwise called the quotient of powers rule. Let's say I have something that looks like this, and we'll look at a simple example first. If I have something like x to the 5, and I divide that by x to the 2, well, I can expand that with multiplication. That would be x multiplied by 5 copies of itself. There's x to the 5, and we're dividing it by 2 x's. Okay. Now, happy days, we can get out our cancellation pen because x divided by x is just 1. So this x divided by that x is 1. 1 multiplying something doesn't change it, so we don't usually write that down. Come to think of it, those two cancel as well. So notice all of the stuff on the bottom will cancel that amount of stuff on the top. So basically, what we're noticing here is that we would have had as many copies on top minus however many copies we had on the bottom. So in these cases, you subtract exponents. And this is a good time to ask yourself, why am I going through and showing you how to learn all these rules or prove all these rules to yourself? The reason is because you'll forget. It's very common to forget these different rules, but if you remember that you can expand things with multiplication and use that to remember the rules, you'll never forget, because even if you forget, you reteach yourself. So anyhow, there we go. That would be x to the 3. In this case, well, let's write out this juicy problem here. That's not that juicy, but we'll pretend it is. Okay, so we've got 27 x multiplied by y to the 3, all divided by 3 x to the 8 y to the 7. Okay. Well, first of all, 27 divided by 3, we could write those as powers of 3 and use our power laws, but we know that that's just 9. Okay, it's 3 squared, because 27 is 3 cubed, and 3 is 3 to the 1. So 3 to the 3 divided by 3 to the 1 is 3 to the 2, or 9. Okay, so we can use our exponent laws there, or you can just know that 27 divided by 3 is 9. So let's keep going. And then we would have x to the 1 minus 8 up there. That's this x to the 1 minus x to the 8 multiplied by y to the 3 minus 7. Okay. And now we stubbornly apply our algebra and find that this is 9x to the negative 7, y to the negative 4. Oh, but this question asks for positive exponents only. So these are negative exponents. They don't want that, and you'll sometimes see that on the SAT as well. Write this with positive exponents and tell us what they are. In this case, it would be 9 on top divided by x to the 7, y to the 4. This is a set of instructions, same as that, equivalent, saying we're dividing by 7 copies of x and 4 copies of y. Right? Another thing that we can do is if you have something that looks like this, is you can just use a negative exponent, like something like x to the negative a. That negative exponent, you can just think of it as a set of instructions saying kick the whole thing downstairs. It used to live upstairs, but now it lives downstairs with a positive exponent. And similarly, if you had 1 over x to the negative a, well, you could write that as x to the positive a. The negative exponent just changes the floor that the base lives on, that the power lives on. All right, so let's write in our answer. This is 9 divided by x to the 7, y to the 4. We get the green check mark of we got it. Okay, so these are our basic laws, these 3 laws: multiplying powers, raising powers to powers, and dividing powers. Now let's go see how we apply those in these mixed power problems. Okay, so these mixed power problems give us, here's another dividing powers with the same base. Here is raising powers to powers. There is multiplying powers. We'll do one here. This one is 27 x to the squared and y to the 3. So practice a lot of these and get very fast at them, because you want to have these mixed power problems to be very quick. This one will be 36 x to the 5, y to the 3, for example. It just wants to be very fast with these skills. And then you can try them in just a little different presentation here. Like these ones are a little bit more straightforward, but again, you can practice these quickly. This one here is 8q squared. 8q cubed. Very common would be to say 2q cubed, and it's not that. It's definitely 8q cubed. Okay. If you're having mistakes, look through Delta Math's explanations. It's very useful. Okay. And then let's take a look at now some negative exponent questions. So we want to get very good at working with these negative exponents. In this case, we have x to the 6 divided by x squared. So that's going to be x to the 4. Okay. Just practice these. Get very fast at these types of questions. Oh, here, this one's more interesting. X to the negative 6, y to the 4, divided by x to the 5, y to the negative 7. Someone likes the number 11 here, because this is y to the 11 over x to the 11. And you too want to be that fast at these. Maybe you're like, well, okay, show me one. Why is that? Because these won't show you answers because they're multiple choice. So let's take a look. If I have x to the negative 6, y to the 4, divided by x to the 5, y to the negative 7, I just stubbornly apply my laws. That's x to the negative 6 minus 5. That's the exponent up there. And then this is y to the 4 minus 7, which is equal to x to the negative 11, y to the positive 11, because subtracting a negative is like removing a debt. It's like basically giving you money. So that's y to the 11. So then this one gets kicked downstairs, and it's no longer a negative exponent, so now a positive exponent. We're now dividing by 11 copies of x. So that's why that one will give me the green check mark of you got it. So those are nice. So practice those, and more just practice your exponential rules here. So let's take a look at these. Here, express the following fraction in the simplest form using only positive exponents. Well, that's going to be v to the 6 on top and v to the 5 on the bottom, so it's just 2v. Get very fast. Very fast at these. Practice several of them until it's very, very fast. Okay, let's look at the more challenging versions. All right, express this one in simplest form using only positive exponents. I'll do this one in my head, and then I'll show you writing it out the next one. So this one will be 3 to the 5 on top. 3 to the 5 is 243, but 12 has a factor 3 in it. So we can actually reduce that to 3 to the 4. So 3 to the 4 is 81. So we're going to have 81 on top, but it's negative. Why is that still negative? Well, it's still negative because negative 3 multiplied by itself 5 times, that's 5 multiplications of a negative. And it would go negative, positive, negative, positive, negative. It's like hitting a light switch 5 times. So it will be in the off position. Okay, and now u to the negative 3 raised to the power 5 is to the negative 15, divided by negative 9 is going to leave us negative 6. So it's going to be u to the 6 on the bottom. And then there's going to be an h to the 5 on top. That should do it. Oh, wait, I forgot the 4 on the bottom. Yeah, the 12 has a factor 3, but we removed it. It leaves a factor 4. There. Simplest possible fraction. Okay. Okay, so you want to get good at these. You want to be fast. So let's take a look. Here, let's do this one. No, that one's not as hard as the one we just did. That looks okay. That's better. I'm kind of looking for something very specific here. So bear with me. There we go. This one's good. This is very similar to the question we just answered. Fine. Okay, so let's do this one on the paper. Okay, so here we go. First, we copy it out. Now that we've gotten it copied out, we just take it apart. So here, I will write it as minus 3 to the 5, x to the 5 times 5, or 25, and m to the negative 15. That's working that power 5 in, so I've just done that thing. And then 12, it's going to be helpful to write that as 3 times 4. That's 12, broken down into almost its prime factors. 4 is 2 times 2, but it doesn't benefit me to break that down. So I'll write it as 3 times 4. I have no 2's on top to cancel. Anyway, then x to the minus 1, m squared. All right. So now this one here, that's 3 to the 1. That's going to cancel one of those 5's and make that a 4. But be very careful because it does not cancel the negative there. So here's what I'm saying. Negative 3 to the 5 divided by 3. Okay, this is equal to negative 3 divided by negative 3 multiplied by negative 3 multiplied, wow, look what my brain does. Can't even write anymore. Multiplied by negative 3 when I say something wrong. Divided by 3. This 3 can cancel one of those 3's, but it still leaves a negative 1, right? And when you multiply negative, this is now a positive. It's now a negative. It's now a positive. It's back to negative. Okay, so it's important to get the sign right. If you get the sign wrong, then you're wrong, and you don't get those points. The sign errors are the most common errors. You've got to be careful with this stuff. Okay, so That is to say that we end up with negative 81 up there, like we did in the problem I did earlier. X to the 25 minus minus 1 is x to the 26, not 24. Okay? And m to the minus 15 divided by m to the 2, that's in total a set of instructions saying divide by 17 copies of x, of m, sorry, and multiply by 4 on the bottom. So negative 81, x to the 26, negative 81, x to the 26, divided by m to the 17. I almost forgot that 4 again. There. Practice these. These are really like practice a lot of your rules at the same times questions. Okay, cool. Next, we're going to get into some more advanced stuff here where we look at fractional exponents. So let's take a look at that and break those down. Exponential and radical form in here. Right, here we go. So square roots and exponentials are essentially the same thing, and they happen at the same layer in bedness. So let's just say we had something like this. If you we've looked at integer exponents so far, but what if we had something like, let's say, x to the 1 over 3? What is that? What's x to the 1/3? Well, here's something I know about it. If I had x to the 1 over 3 multiplied by x to the 1 over 3 multiplied by x to the 1 over 3, well, I can use my product of powers law to say that this is x to the 1 over 3 plus 1 over 3 plus 1 over 3. Okay, so what is that saying? It's saying that that would in total be x to the 1. All right, so this is like a set of instructions saying x to the 1/3 is the number that when multiplied by itself 3 times gives you x. So that's what this denominator is doing in the exponent. In other words, let's say I'm looking for 27, okay, as a total, and that's equal to some number raised to the 1/3 multiplied by some number raised to the 1/3 multiplied by some number raised to the 1/3. Okay. Well, what thing times itself 3 times is 27? Well, 3. Okay, 3. 3 times 3 times 3 is 27. So in this case, x to the 1/3 equals 3. All right? And if you look at it, another way of writing that would be the 3rd root of 27 is equal to 3. This is a set of instructions saying, go find me the number that when multiplied by itself 3 times gives you 27. Or another example, let's say we said the 3rd root of 125. Well, that's just 5. 5 times 5 times 5 is 125, and 5 times 5 times 5 times 5 is 625. Anyhow, so 5 is the 3rd root of 125. In other words, 125 to the 1/3 is the same thing as 5. That's another thing. And it would be the same thing as writing this. So this is what we're up to when we're using fractional exponents and how we can start to understand what a fractional or rational exponent means and how to evaluate it and interpret it. Okay, it's very similar to this idea. So another way that we might write that is like, say, 9 to the 1/2. What is that? Well, it's just 3. Because 9 to the 1/2 multiplied by 9 to the 1/2, well, that would just be equal to 9 to the 1/2 plus 1/2, or 9 to the 1. And another way of writing this, 3 times 3 is equal to 9. Okay, so it's just that simple. So one of the skills that you'll want to have is being able to move between the two forms. And here's the general way that it might be written down, that we can write it down. So if we have something like x to the a over b is our exponent, well, we can write that as the b root of x raised to the power a. Or I prefer to write it this way, the b root of x all raised to the power a. So for example, let's say I have 216 and I raise that to the 2/3. Okay. Well, I can write that as the third root of 216, and I want to square it. What will that be? Well, the third root of 216, you can check your calculator and find that that's 6. 6 squared is 36. Okay, so 216 to the 2/3 is 36. That's what it is. And this is how we can evaluate it, by breaking it down using radical form and understanding it that way. Okay, so another example. Let's take a look at another example. 625 divided by, we'll go with 81. And we're going to raise this to the negative 3/4. All right, let's go through this one. I like these types of problems. So how do we evaluate that? One thing we can do is just crank it into a calculator, and the calculator will tell us. It will probably tell us a decimal, and decimals are hard to code on the SAT. So, well, weird, janky ones. Anyway, with this one here, here's how I would break this down. First, let's do the negative exponent. So this is going to be 81 over 625 raised to the 3/4. Why? Because that negative exponent says anything living downstairs goes upstairs, anything living upstairs goes downstairs. If I have a over b raised to the negative x, that's the same thing as b over a to the x. And to go one step further, this is b to the x over a to the x. Okay, so that's all your basic exponent laws there being applied to fractions. Okay, and now we're going to write this in radical form. So this is the fourth root of 81, all raised to the 3, divided by the fourth root of 625, all raised to the power 3. Okay. The fourth root of 81 is 3. The fourth root of 625 is 5. And we're going to cube this thing, okay, because it's all being raised to the power 3. So that's the same thing as 3 cubed over 5 cubed, and that's the same thing as 27 over 125. That's how these work. Now let's take a look at some delta math problems that we can use for practice to get these skills. Okay, so if we were asked to write this in radical form, x to the 2 over 5, you would write it this way. Well, you would say this is the nth root, the fifth root of x, and we want to square it. Okay, this is the, write this expression in exponential form. Well, this is x raised to the power 4 over 3. So again, we want this at unconscious competence, has to be very fast. This is basically just a notation type question. Okay, so get good at that. And then if we have exponential rules, but there's fractions involved, well, we can apply our fractions here as well. So this is b to the 6 multiplied by b to the 5, all raised to the power 5 over 44. So this is going to be b to the 5 over 4. So that's this one. How do I know that? Let me show you. Okay, so we write it out. B to the 6 multiplied by b to the 5, all raised to the 5 over 44. Hi. So this is add the exponents together when multiplying exponents of the same base. This is b to the 11 inside the brackets raised to the 5 over 44. Okay. Now we apply our power of powers law. So we multiply exponents. This is b raised to the, let's do our scratch work over here. 11 times 5 over 44. 11's living upstairs and 44 lives downstairs. 44 could have been written as 4 times 11. So the 11's cancel. Leaves us 5 over 4. Okay, and then once we get to this level, because we have this skill, x to the a over b is equal to the b root of x raised to the power a, we can just directly go to this and know that that's correct. Yeah. So you want that level, you want this level. Oh, so this one, select the equivalent expression. So we went with the 16th root of a to the minus 6 over a to the 2. a to the minus 6 over a to the 2 is the same thing as 1 over a to the 8. And so that's going to end up being 8 over 16, but negative. So this is a to the negative 1/2. Get this to the very fast, very comfortable level, and you'll be happy with exponential things. Okay, so those are those skills. Radicals and fractional exponents on integers. Let's take a look at this skill. So if we have the 10th root of the 6th root of 10 multiplied by the 6th root of 10, what is that? Well, it's the 3rd root of 10. Hooray. So put it in exponential form, add the exponents together, reduce your fraction, 10 to the 1/3, and then that's what they wanted. Also, the 3rd root of 10 would have been the same thing. Would have been another possibility. So if we have something like this, okay, so go to exponential form. That will be 3 to the 3/5 multiplied by 3 to the 4/5 gives us 3 to the 7/5. There it is there. Hooray. Okay, so just practice. This is all just practice. Okay, and then solving equations with fractional exponents, combining radicals and fractional exponents. Let's take a look. You could get some stuff that looks like this. Okay, so we want to find the value of a in this question. This is actually set up a little bit like you might see an SAT question. It's not just skills practice. So here, the 3rd root of x, let's copy it out. Copy out the question. The 3rd root of x divided by x to the 1/3 raised to the power 5. Okay, well, let's go to exponential form. This is x to the 1 over 3 divided by x to the 5 over 3. Now we subtract our exponents. So this is x to the 1 over 3 minus 5 over 3. Gives us x to the negative 4/3. So a is negative 4/3. Unless this is the first mistake that I've made all video. No, it's not. Okay. So here we do the same thing. This is x to the 1/5 divided by x to the 6/5. So we're going to have x to the negative 1. So this is just negative 1. Fast with these. Look at the solution. Go to the exponential form, subtract the exponents. It's just negative 1. There you go. Yeah. So practice, practice, practice. Practice all these skills. Combining radical and fractional exponents. These are just a little bit more challenging. Okay, so now here we can write these things as a times x to the b times y to the c and simplify all of the exponents and simplify the numbers to number a. Okay, and then we want the product of a, b, and c. These are so set up like SAT questions that we're including them in our practice as well. They're useful skills too. This is really useful. So if I'm going to copy it out. So once it's proudly copied out, we can make our page big and we can go to exponential form. This is, we're going to go to exponential form. I'm not going to skip any steps. 16x to the 3, y to the 4, raised to the 1/2. Okay, all divided by 4, x to the 7 over 4, y. Now we need to do this in Bedmas order. So we have to do this exponent first before we do the division. Okay, the exponent comes first, and then this division comes second. All right, so let's go ahead and do just that. We're going to do that exponent on top. 16 to the 1/2 is just 4. Okay, that's the square root of 16. In other words, that's why I was like, oh, we could skip steps, but let's not. X to the 3 to the 1/2 is x to the 3 over 2. We multiply the exponents. 3 times 1/2 is 3/2. And then 4 times 1/2 is 2. So this is just y to the 2 divided by all this stuff that's on the bottom. 4x to the 7 over 4 y. Okay, now let's keep going. All right, 4 divided by 4 is 1, so we don't write anything. X to the 3 over 2. I'm going to write that as x to the 6 over 4 for reasons that will immediately become apparent, minus 7 over 4. Okay, just prepare my common denominator, multiplied by y to the 2 minus 1. So there's my exponents. because that's y to the 1 over there. We're going to subtract those exponents. So 3 halves minus 7 quarters is the same thing as x to the negative 1 quarter y to the 1. Okay, and then now it's in the form a x to the b y to the c, and they wanted to know is the answer the value of a times b times c. Well, a is 1, c is 1, and b is negative 1 quarter. Therefore, this is a big shocker here. The answer is negative 1 over 4. Okay, so that's how you do these and practice these skills. Let's go. Now here, this is a little more fun. Okay, find a positive solution to the equation. Now we're adding new skills. Now we're adding some new skills here that we haven't seen yet. So these are inverse operations questions. How well can you manipulate equations and find unknowns? A valuable skill for the SAT and a valuable skill in math and life generally. So let's take a look. 3x to the 2 over 7 minus 27 equals 165. Well, our first step here is going to be to add 27 to both sides. And so then we will get 3 to the 2 over 7. Sorry, 3x to the 2 over 7. Equals 165 plus 27 is 192. Okay, 192 is divisible by 3, which is good news because we're going to divide by 3 to isolate x to the 2 over 7. All right, and so then we're going to go ahead and get ourselves, well, what is that? 192, that is 64. Okay, so x to the 2 over 7 is equal to 64. I'm a little surprised, actually. It's a little bit annoying. Oh, wait, no, it's not. No, it's not that bad. Okay, so now, once we've got it here, there are fancy ways to solve it and calculator ways to solve it. Let me show you the calculator way, because the calculator way is much more universal. The fancy way only works when the problems are nicely designed, like this one. Okay, so let's take a look at the calculator way. If I want to know what x is, what I can do is a very special inverse operation. I'm going to zoom in on it because you're going to want to notice this. If x to the 2 over 7 is known to be 64 or some value, then what I can do, and that didn't, oh no. Oh no. Okay, I've rewritten the question for us. So here, another thing I want to highlight. This may be jarring, but let's take a look at the solution so far. First thing we did up here was deal with any loose addition and subtraction. We notice this minus 27 is actually really easy to move, and we can move that before we divide by 3. Makes the whole thing easier, right? Once we've got all of that consolidated on one side down here, that's when we can deal with multiplication and division and moving those across the equal sign by their inverse operations. So here we were subtracting, so we added. That was an inverse operation. Here we're multiplying by 3, so we divided. It's an inverse operation. Now we're going to take a look at the inverse operation that we're going to use to clear the deeper layer, which is the exponent. The exponent's going to come later. And now let's take a look at what we can do. So here our inverse operation, and when we have rational exponents, this is very useful, is we just raise both sides of the equation to the reciprocal exponent. Because here you see, we would be multiplying the exponents over there, and 2/7 times 7/2 is 1. So that will isolate x. You'll end up with x to the 1 on one side of this equation. So let's do that. So here we can write this as x to the 2/7 times 7/2, or x to the 1, is equal to 64 to the 7/2. So that's the same thing as saying the square root of 64. What is the 2 doing in there? The square root of 64 raised to the power 7. Or in other words, square root of 64 is just 8. So this is 8 to the 7. 8 to the 7 is the same thing as saying 2 to the 21, which I don't happen to have memorized. So let's find what it is. 8 to the 7 is 2,097,152. 2,900,172. I feel like that doesn't resemble a number at all. 97,152. Okay. And check it one more time. That's good. Hold on. Okay, just had to refresh. Let's see. Hooray. Okay, so that's how you can work on these. And that's an important skill, is knowing how to move an exponent away from an unknown so that you can solve for it. Raise both sides to a reciprocal exponent. Now, many students get a lot of fluency, say, working on stuff like they will have an equation like, 81 is equal to x squared. And then they know to take the square root of both sides, but one of them has to be plus or minus. Okay. Notice that the question was saying, give me only the positive one. Okay, and so in this case, we would have plus or minus 9 is equal to x. That's great. Okay, but let's take a look at it with this method. It's exactly the same. 81 is equal to x squared. So as an inverse operation, let's raise both sides to the 1/2. That is the same thing as taking the square root of both sides. For rigor, we should have plus or minus. We're so often just interested in that positive solution anyway that, we'll see. Yeah, we're oversimplifying, but on the SAT, this is not going to come in that much. Anyway, so it's just 9 is equal to x, because 2 times 1/2 is 1. That's why this works and why this works, because they're exactly the same thing. This method is nicer because it expands out to other things. Like, let's say I have 625 is equal to x to the 4/3. Okay, and I want to know what x is. Well, we would, again, raise both sides to the 3/4. And when we raise 625 to the 3/4, you find that 125 is equal to x. Check your calculator if you don't trust me. All right, so practice these skills, get to a high level with your exponents, and that will really help us on exponent laws. When you have problems with these questions, absolutely screenshot them and email them to me and ask your question. I will help you out as best I can. Thank you so much for showing up for your learning. Bye for now, everybody.